Hello folks, welcome back once again. This is yet another video in the series where we are actually going to discuss a few things about like programming in Java using BlueJ environment. So the previous video was all about like bubble sorting and application of arrays, and this video is again going to continue on like some of the applications of arrays. So hope you've actually watched the previous videos on introduction to arrays before watching this video. So I've dedicated this video for this problem. We have an array of elements, basically integers, and we have to find out, or basically we have to search a given element in an array. Say for example, the user inputs 5. The user wants to search an element called 5. The key element, we name that element what the user actually wants to search is the key element. That key is equal to 5. Now we have to write a program to see if the number 5 is present anywhere in the array. And if the number is present, we also try to actually figure out what is the index location of the array at which that number actually is found. So this is basically using linear search. And after the linear search, I'm actually going to extend the same video, continue with the same video, trying to explain the logic and also the program for finding out the largest number in the array and the smallest number in the array and printing them along with their positions. This video actually is pretty much important, especially the part which is going to deal about like finding the largest number of an array or the smallest number of an array along with its position. That's going to be the fundamentals for the next video, which is going to be on selection sort. So if you actually want to be really comfortable understanding selection sort, you must have a good understanding of this video and how we actually develop the programs. Now let's get started. Linear searching is nothing but, say the user actually inputs a number called 5 and I store that number called as in a variable called key. So the key number what the user actually wants to search is 5. So how do I search? So what do I do is I check if 5 is located in A of 1. Is 5 equal to -1? No. I increment the pointer. Is 5 located in A of 0? No. A of 1. What is A of 1? A of 1 is going to be 0. No. Is 5 located in A of 2? No. A of 2 is 1. Is 5 equal to 2? No. Is 5 located in A of 3? Yes. Key element is equal to the element stored over here. So we stop the processing and then we say yes, element found. Yes, the element is found. So the for loop is going to look like this. For the array size is going to be, it has 7 elements in the array. So int size of the array is going to be 7. And then for I equals to 0, I less than 7, because we have to traverse from 0 to 6, so it's less than 7. Or I would say I less than size of the array. And then we say I plus plus. Close the bracket. What do we do? What do we do here is, if A of I is equal to key. It's not A of double I, it's just A of I is equal to key. If that's the case, then what we do is I declare a new variable, say flag. Flag is equal to 0. If I find the element, I update a flag. That's very important. If you find the element, you just update the flag and you set flag is equal to 1 and then we call break. We just call break. Yes. Now once you actually come out of this for loop, what you check is if flag equals to 1, it means you have found the element. So element found. Else if flag remains 0, then element is not found. Just listen carefully over here. Pay attention what this flag variable does. Say for example, the user actually inputs a number, say 100. Now you'll understand the importance of flag. The user actually inputs a number, say 100. The key element what we want to search in this array is 100. So what we'll do, we'll again reset the I back to 0 and we are traversing this array starting from location 0. So is the element actually found in A of 0? Is key, or if A of I equals to key. What is A of I? What is I? I is 0. What is A of I? A of 0. What is A of 0? Minus 1. Is minus 1 equal to 100? No. Is the key element found over here? Is 100 found over here? No. Is 100 found over here? No. Is 100 found over here? No. 100 found over here? No. 100 found over here? No. Is 100 found over here? No. And by the time the loop would have finished executing and exited. When it exits, it would have never entered this block because A of I is equal to key. This condition is not even satisfied once because the element is not found. So how do we check if the element actually is not found? We check for the value of flag. If flag is equal to 0, it has never entered this block, so we say element is not found. If flag is equal to 1, element is found. What would be the value of the position where the element is found? Element is found at position I. Because when it breaks out at this part, it's not going to continue executing the loop anymore. So whatever was the value of I, it would break out immediately. Alright? If the element is not found, we really don't have to worry about printing the position because the element is anyway not found. So when the loop actually stops executing, when flag is being set to 1 and we break out of the loop, whatever is the value of I, that's going to be printed over here. Suppose say the user actually inputs 5. So 5 actually is found in A of 3. The value of I here, suppose the user actually enters a key as 5 and the key element actually is found at A of 3. When we enter this block, if A of I is equal to key, it's basically A of 3 is equal to 5. So the value of I, so here I is equal to 3. Right? We break. We no longer continue executing the loop. So the element actually is found at array index 3. The position element is found at position array index I. Whatever is the value of I, the loop will no longer continue to execute because it is breaking. This is the break statement over here. The loop will no longer continue to execute. It's just breaking out of the for loop. Then we actually see the position of I is nothing but the position I has a value whatever I was having over here. Alright, hope this is clear. Let's write the code for this. I just have to copy this. Like I have to even copy this first. Open the BlueJ editor. It's a new class, linear search. So let me create a class by name linear search and end the class over here. And just write the main function. And let me copy down the array. Yes. And how many elements here? Size is int. Size of the array is going to be equal to 7. And I want to search how many. I need a variable called I. And let me say the key element I want to search is equal to 5. Alright. The key element I want to search is equal to 5. So let me copy the rest of the code from the WordPad over here. We need flag and we need this loop. Just copying it. I'm not doing anything extra. If you understood this part, then there's nothing new to understand in the program over here. It's just a copy paste of that, except key is equal to 5 and I would say int flag is equal to 0 and get rid of the flag over here. I don't need size over here. For F has to be in small letters. All the small typing things. Yes. This thing is important. This thing is very important. Yes. And now I have to do the checking. If flag equals to 1, then I have to print system.out.println element found at index. What is the index? Plus I. Else system dot println it's element not found. Alright, let's compile it. That's it. The program is as simple as that. It's not as complicated as you think. Okay, the main function ends here and the class ends here. Let me actually try to squeeze everything into the same single window so you can actually see the logic. I'm going to clear some space over here. Cool. And this thing out here. Right. That's it. Let me enlarge it. Hope this is clear. This is linear search. Compile it. Identifier expected. I don't have to give int flag once again. I just have to give comma followed by flag. Compile it. Okay. Semicolon. Compile it. If a of I equals to key. Why is that? It's telling me expected that over there. A of I. Why is that so? Why is that expecting me to print something over there? It's capital I, typo. It has to be small I. Compile it. Not a statement. Again, it has to be small b, because we just try to type it in the word pad and everything is by default. The beginning of the line is going to be by default in capital letters, so everything was copied in capital letters. So close it. So then let's call the main function, run the program. Oops. Clear the previous output, close it, call the main. Call the main. Element found at index 6. I'm not happy with this. Element is certainly not found at index 6. If flag is equal to 1, we are breaking out of the for loop anyway. Okay, if flag is equal to 1, okay, we're breaking out of the for loop. Say, okay, we're not breaking out of the for loop in that case, we're just breaking out of this block. We're just breaking out of this block. So what do? I need another variable, say position is equal to 0, and as soon as I actually find the element, I store the index location of I into this local variable called as position over here. So I say now position is equal to I. I now print position as the index. I hope it's clear. When I enter this block, whatever is the value of I, the index location at which the element which we are searching is found, I'm storing that location in a third variable, another variable called as position. So, and then what happens is I'm printing the position out here. That's it. Nothing new. What name? See, clear it. Clear, close. I'm searching for key element 5. Yeah, 5 actually is found. 5 actually is found. Okay, you don't need this. You don't need position is equal to I. Just I would do. I would do. A position I would do. I don't need a third variable called position. I would do. Okay, now say I want to actually search the element called 0. Compile, close, linear search, main. Element found at index location 3. Now let's look at where is 0. Now in this program 0 actually is at different locations. It's a sorted array. If you look at the original array, if you look at the code, 0 actually is found at, this is 0th location, first location, second location, third location. So index of 0 is 3. Starts from 0. 0, 1, 2 and 3. What is the output we got? Element found, keeping it back. Element found at index 3. Now let's actually give a number 100, which is, or 110, which is not there anywhere in the array. So we are supposed to get the output as element not found. No syntax errors. Close it. Clear this output. Then close this thing. Call the main function. See, element not found. This is all about linear search. It's a very simple program. Now we have to actually see how to modify this program to figure out the largest element in the array. Largest element in the array. So let's close this thing. and let's get back to our WordPad. So the elements over here are stored in the order of, you know, -1, 0, 1, 5. Okay, this is kind of like sorted. I don't want to jumble it. I want to shuffle it up. I don't want it to be in this way. I want it to actually, you know, like jumble it up a little bit. Alright, this is good. The largest number is not found in the last position. Okay. So the array elements are -1, 8, 1, 5, 15, 9 and 0. 9 and 0. Let me have this pointer here. Let me get rid of this because we are almost like done with, you know, linear search. Now we have to search for the largest element in the array. The first thing what I'm supposed to do is I'm going to declare a variable called as int big is equal to a of, you know, like I'm going to make the biggest number as a of 0. So what is the biggest number now? Big is going to be equal to -1. Alright. The first step I'm actually going to do in finding the largest number of an array is take the first element of an array and assign it to a variable called big. Big is equal to -1. Or say, I would say this is the biggest, in fact. Biggest. This is our assumption. So the first element of the array is going to be the biggest element. Now what do? We compare the first element of the array. We compare the first element of the array with the second element. Is -1 greater than 8? Certainly not. -1 is not greater than 8. Then what do? We assign biggest is equal to 8. Okay? We assign biggest is equal to 8. Then we move on. We increment the pointer to this location. Let me actually keep it in the end over here. Or let me cut this and paste it here. This makes sense. We initialize the biggest element to the first element of the array, and we keep checking the next element is it greater than the biggest element. So now, is 8 greater than 1? Certainly yes. We don't do anything. We move on here. Is 8 greater than 1? Nothing. We move on this location over here. No, we actually check is 8 greater than 1? Wait a minute. Initially, we check is -1 greater than -1. We first check if -1, the biggest element, is it greater than the first element in the array? No, -1 is not greater than -1. So we don't do anything. We just go ahead. Is -1 greater than 8? Certainly yes. I'm sorry, is -1 greater than 8? No. If the condition fails, then we have to make, there's another biggest element. Biggest is equal to 8. Biggest is now equal to 8. We again increment this. We again check, is 1 greater than biggest? No way. Keep going. Is 5 greater than biggest? No way. Keep going. Is 15 greater than biggest? Is 15 greater than biggest? Certainly yes. Yes. So I make 15 assigned to biggest. Now, is 15 greater than 15? Certainly not. 1. Is 9 greater than 15? Nope. Is 0 greater than 15? Nope. So when you actually finish traversing the entire loop, what do you get? The biggest element is stored now in the variable called biggest. That's it. So the first step is we are assigning the biggest number to a variable called a of 0. Assigning the a of 0 to a variable called biggest, and then we begin to traverse the loop. How do we do that? Okay, for int I equals to 0, right? I less than size of the array, and we go for I++. What do we do in each step? in each step we check if A of I is greater than biggest. Is it greater than biggest? If so, if that's the case, what do? We do biggest is equal to A of I. It's simple. We just check if -1 is greater than -1. No. We move on. Loop actually continues to execute. Now what do we get? What was the previous value of biggest? Biggest is equal to A of 0, which is going to be -1. We are going to check if 8 is greater than -1 in this step. Yes, 8 is greater than -1. Then what is biggest? Biggest is equal to A of I. So now we are actually assigning biggest is equal to 8. That's what is happening in this step. Alright? That's what is happening in this step. That's all. That's all. The biggest element can be found out. The biggest element can be found out. In a similar way, you can also find the smallest element. I'm just like leaving that as a homework exercise for you, how to actually find out the smallest element. It's just a small modification in the same code. Now, we have another part remaining in this. How do we find out at what position is the biggest element found? That's a little tricky. How do you find out at what position is the biggest element found? What did I do? First, I assigned biggest to -1. I checked if -1 is greater than -1. No. Increment this to the next position. I'm now actually checking is 8 greater than -1. Certainly 8 is greater than -1. Then now I actually assign biggest to 8, or I assign 8 to biggest. I increment my pointer in the array. I increment my location tracker, whatever you call it. That's nothing but a variable I over here. The pointer over here corresponds to the variable I. And now what happens is like, is 1 greater than 8? Is A of I greater than biggest? No, 1 is not greater than 8. Keep moving. Is 5 greater than 8? No. Keep moving. No, wait a minute. Come back here. What happened when you actually checked the first? Let's start from the first. What happened now when you actually checked? What happened now when you checked? -1 is greater than -1. Say the biggest is initialized to -1. No. Increment it. Now, what happens now when A of I is greater than biggest? Now, biggest is equal to A of I. Now, what is happening? When we enter this block, you think something can be done over here? Just think for a minute. When we are entering this block, for time being, the biggest element is found wherever I actually is found. The biggest element was found whatever is the location of I. Until this point, we haven't traversed the rest of the array. Until this point, for us, the biggest element is at array index 1. So what do we do here is, we create another temporary variable called position and initialize it to 0. Okay. So what happens is, we record the position of I. So we say position is equal to I. Because this is where the largest element for us is found. If you're entering this block, it means that a largest element is found here. But we haven't traversed the entire array. Say at this point, the position of the value of I is going to be equal to 2. So if our array actually was only just 2 element long, the largest element is found at location 1. So I is equal to 1. So we are recording whatever was stored in variable I in another third variable called position. So position is now equal to 1. So we continue. We just do the small addition over here and we continue to the next step. Is 1 greater than biggest? What is our biggest now? Biggest is 8. 1 is not greater than biggest. We are not going to enter this block. Keep moving on. Is 1 greater than, is 5 greater than biggest? Biggest is 8. Is 5 greater than 8? No. A of 3 is 5. So we again move on. Now what? Is 15 greater than biggest? Certainly yes. So if A of I is greater than biggest, I is equal to 4. We are going to enter this block. And now we have found a bigger element, so we are recording the value of I, which is equal to 4, and storing it in position. And then biggest is now 15. What happens if we actually increment this and move further? Is 9 greater than biggest? No. Keep moving. Is 0 greater than biggest? No. Is 0 greater than 15? No. But by the time this loop would end. So when you come out of the loop, if you print biggest and also print the position, this is going to give you what is the biggest element, because the value of the largest element found in the array is now stored in the variable called biggest, and then the position where it was found, we have already safely recorded this to a variable called as POS. That's it. That's all is the code to actually find out the largest element in the array and also its position. This piece of code is of fundamental importance for understanding how selection sort actually works, which is going to be the next video. So if you want to really understand selection sort, you have to understand how to find the largest or the smallest element in the array along with its position. So me having explained how to find the largest element in the array, it's a very small modification which any one of you can do to find out the smallest element in the array, which I would recommend you to actually write the code and work it out for yourself. Now let's actually see whether this code actually works for the largest element of the array by just copying this into a BlueJ editor. I just have to, like clear everything up and keep it like clean and just paste it here. All I have to do is I have to create int biggest is equal to a of 0. This is the only step I have to add here. And then I have to give position is equal to 0. I have to get rid of position over here. Then if a of I, this has to be in small letters, everything has to be in small. Position is equal to I. Then what I'm supposed to do is going to give you, like system dot out dot println largest element is, the largest element is going to be biggest plus a space followed by found at index POS, because POS is a variable which is actually storing the position of the largest element found in the array. Okay, it's gonna be this thing expected where here. Okay, compile it. What happened? Okay, found at index, it's going to be another plus over here. Yeah, compile. What happened? Okay, I don't need this. I don't actually need biggest. Largest element is biggest. Okay, plus found at, it's just like I is already defined. I don't have to redefine it here. Yeah, cool. Bad operand type found at index. Okay, fine, I agree. I don't need this, Found at index. Okay, hope. Yes, finally, yes. Close it and call the main function. We have to clear the previous output, close it, and rerun the program by calling the main. The largest element 15 found at index 5. Let's open the program and let's actually compare it with the actual output in the terminal window. The largest element is 15. It's found at index 5. Okay, definitely in this array the largest element is 15. And what did we get the output as? We got the output as it's found at index location 5. Certainly 5, because this is 0, 1, 2, 3, 4 and 5. This is the index location 5, starting from 0. That's what we are actually trying to print. So that's it all about finding the largest element and finding the index location. You can also like jumble it up if you don't want to do this thing as like 15. Say I can keep 0 over here, and I can keep, say, 300 is the largest number. 300 is the largest number. I just made a small modification to the original array. Now 300 should be found at index location. This is 0, this is 1, and this is 2. So we have to get the output of this program as the largest element 300 is found at index location 2. Let's run it. Let's clear the previous output and close the output screen and call the main again. See, the largest number 300 is found at index location 2. That's it for now. So hope I find this video interesting, and hope it's of some use for you. That's all I intend to do now. For the next video, I plan to cover up selection sort and the fundamentals which I discussed in this video about like finding the largest number and its index location is very, very important. That understanding is very important for understanding selection sort. So make sure you understand this video thoroughly before actually watching the next video, which is going to be on selection sort. And the homework assignment for you would be like trying out a program in a similar way to find out the smallest number in an array and also its location. It's a small modification, but you should be able to do it. And that's it. Goodbye for now. See you back again in the next video.